topic for today is set notation and the Venn diagram. Okay, today the topic we have today is set and the Venn diagram. Okay, without wasting time, let's begin. Okay, first, what is a set? Because we sometimes have to define a set. A set is a collection of well-defined objects, a collection of similar things, a collection of similar things that are put together. Okay, like for example, if you take a mathematical set, you see all the things that are inside, they're very similar. You have the pair of divider, pair of compass, you have protractor, you have ruler, you have sharpener, you have eraser, you have pencil, and all of these things. So it's a set of mathematical tools that are used to help you to solve your problems. If you have your wardrobe where you keep your clothes, it's a set of clothes. You have the clothes, different types of clothes, the English clothes, the African clothes, all the different clothes that you have. They will be the Arabia clothes, all the different sets of clothes you have. That wardrobe will be made up of it. You also have where you keep your shoes, a set of different type of shoes. So if you have in case of continents, you have a set of countries of the same continent. For example, you say Africa, you have a set of countries of Africa, all in that same geographical location. If you say Europe, you have sets of countries that are also in the same northern hemisphere of the same geographical location. So a set is a collection of well-defined objects. A collection of well-defined objects or symbols. That's what we call a set. Now the symbols or the objects that are inside the set, they're called the elements. And if something is an element of, let's say for example, South Africa is an element of Africa, or Angola is an element of Africa. So you write Angola is an element of. Insert, an element of is given by symbol letter, small letter E. So you say Angola is an element of, okay, this is how we write element of, this symbol. Element of Africa. Okay, because Angola is a country in Africa. Okay. England or United Kingdom is an element of Europe. United Kingdom is an element of Europe. Okay, so this Angola is just a member of the set called Africa. It's a member of the set called Africa. It's a member of the set that we call Africa. Is that okay? Okay, so that's that for that. This is the first thing we need to know. If anything is an element of is something, you draw something like this and you cross it. Okay, Nigeria is an element of Africa. Okay, Burkina Faso is an element of Africa. So let's go on since we understand this first concept. So a set is defined as a collection of things that are similar that are put together. Collection of similar things that are put together. Now let's take a look at this first example. You say a particular set consists of the following elements. We have South Africa, we have Namibia, we have Egypt, we have Angola. And then it continues. You see this 3 dot means it continues. That's not the end. It's not an infinite set. The first question says describe the set. Describe the set. You should describe the set. Okay, the description is that you say these are elements of set of countries of Africa. That's the description of this set. Say countries of Africa. Just say countries of Africa. Elements of the set of countries of Africa. That's the description for this. Now the next question says add another 2 elements of the set. We should add another 2 elements. So we should add 2 more elements. Okay? So if we want to add 2 more elements, we can choose any country as long as that country is in Africa, because we are describing the set of Africa. So you have to choose any 2 countries that primarily in Africa. Okay, you cannot choose a country in Europe in this set. It will be wrong. Okay, let's say Sudan. We choose Sudan because it's a country in Africa, so we can choose Sudan. Okay, another country, we can choose any other countries in any other country in Africa. Any other country in Africa. Okay, we can choose which other country. Angola was already mentioned. They've given us South Africa, Namibia, Egypt, Angola. Okay, we can choose Guinea. We choose one from the North Africa. We choose one from the West Africa. Okay, so Guinea. So you can see these are. If they ask us for 5 more, you should list 5 more countries only in Africa. Otherwise, if you list a country in Europe, like for example, you say France, that means you're wrong. It's not, if France is not an element of Africa. France is not an element of Africa. If you see this one, this author chose these two countries, chose Zimbabwe and Ghana, chose Zimbabwe and Ghana. So you can decide to choose your countries that you feel that are in Africa. Okay. Now the third question is the set finite or infinite set? Is this set finite or infinite? You know the meaning of finite? Finite is something that ends. Infinite is something that doesn't end. Infinite is something that doesn't end. Infinite is something that doesn't end. It keeps going. Like natural counting numbers, 1, 2, 3 do not end. But countries in Africa, they are finite, right? Countries in Africa are finite. Meaning it comes to an end. There are 54 or 55 countries in Africa. I think we've included South Sudan. Now we have 55 countries in Africa, right? So there are 55 countries in Africa, meaning the set is finite. Meaning it comes to an end. The set can come to an end. So you write finite. You write finite. You say the set is finite. This set of countries in Africa is a finite set. Because it comes to an end, you can count all the countries in Africa and that will be an end to it. Now let's go to another question, question number 2. Or you can call it question B. Now let's go to question number 2. Why we assume this is question number 1. Now we say consider a set A equal to, we use coarse bracket, okay, lest I forget, we use coarse bracket to introduce anything in a set. Anything inside this coarse bracket is defined as element of the set. Okay, so we say consider set A, they've given us set A, and let's see what that definition attains. They've given us set A, they say set A is equal to X. Set A equal to X. This column, you know in English this is called column, but in math or in set it's called such that. Okay, such that X is a natural counting number. X is a natural counting number. X is a natural counting number. So if X is a natural counting number, it means we are saying 1, 2, 3 as it were. Let's say like 1, 2, 3, 4 as it were, okay? 1, 2, natural counting number. 2, 3, 4, 5, 6, as you know, as many as you can count. You know, none of us can finish counting numbers, you know, right? Nobody can finish counting numbers. Numbers do not have ending. So it's an infinite set. In case they ask you, is this set finite or infinite? It is infinite. Why? Why is it infinite? Because it does not have an end. Numbers do not have what? An end. It doesn't have end. Numbers continues. Okay? So I put this one, I can end here, like I close it here. Closing it here does not mean this is the end of numbers. It means we cannot stop. You can only do to the capacity Allah subhanahu wa ta'ala has given to you. Okay? Numbers do not have ending. It's infinite. Now let's describe the set. It says, describe the set. You can say the solution could be is a set of natural counting number. You can say they are elements of sets of natural numbers. Okay? So you can give that as if they say describe the set, you say set A is natural counting numbers. That's it. There is a write down 2 elements of set A. You can write any number. This author wrote 3 and 15. You can write any number. You can write 100 and 1,000. You can write 1,000. You can write 1 million. You can write 800. It depends on numbers that you love or you're familiar with or you want to write. So then let's say they didn't ask that, but let's ask that. Is this set finite or infinite? This set is infinite. Why is it infinite? Because the set do not have an end. This set do not have an end. It's an infinite set. Okay, now let's go to the next question. Question number 3. Although the textbook call it C, but it's question number 3. Consider set B equal to X, Y. S, Y, such that Y equal to 2X minus 4. Okay, so this one, they gave us equation, and they want us to describe the set. So to describe the set, they describe set B. Set B is equal to S, Y, like coordinate, S, Y, but they define the relationship between Y and X. They define the relationship between Y and X. Now let's take a look at that relationship between Y and X. Let's take a look at that relationship. we say y is what? Y is equal to 2x minus 4. 2x minus 4. Now what does this mean? You can find the values of y while you choose the values of x. Let's say we're choosing the value of x from 1, 2, 3, 4, 5, 6, 7, 8. You just choose. So if I choose the first x value, in this case, if I decide to make something like this, if we decide to make something like this, we say here is x and here is y. So we can get their corresponding value. If I choose first one for x to be 1, what would be the first number for y? You say 1 times 2, 2 minus 4, negative 2. So my first y will be negative 2. My first y will be negative 2. Now if we choose 2 for x, number 2 for x, our y will be what? Let's change the color. Our y will be, you come here, 2 times 2, 4, 4 minus 4, 0. Our y will be 0. If we choose 3 for x, what will be the value of y? Y will be what? You come here, you say 2 times 3, because you chose 3 for x. 2 times 3, 6. Right? 2 times 3, 6. 6 minus 4, you get 2. If you chose 4, let's say you chose 4 for x, we stop at 4 or 5. If you chose 4 for x, what will be the value of y? Y will be 2 times 4, 8. 8 minus 4, you get 4 here. If you chose 5, the last one for testing, we're just testing. You can do more if you want to, but so that you'll be able to describe. So if you choose 5, you bring here 5 times 2, 10. 10 minus 4, 6. Okay, now the first question says we should describe the set. It's simply a coordinate, right? Because x, y means coordinate. You say the element of set are the coordinate point found on a straight line. Because this is the equation of a straight line. Remember that? This is an equation of a straight line. Okay? The coordinates, the element of set S are the coordinates of the coordinate of they are the coordinate found in a straight line. Okay? So this will be your answer. The elements of set, which are set whatever they call it, if it's set B, elements of set B are the coordinates of a straight line, you can give the equation. That's it. If they say write down 2 elements of set X, see, you can write 1 comma negative 2, 2 comma 0, 3 comma 2, 4 comma 4, 5 comma 6, and so on and so forth. It's up to you, whatever you want to choose. But once you choose a number, you have to find the corresponding value of X. Okay? You can choose any 2, but must be explicitly tested with this equation. Must be explicitly tested with this equation. Okay, now let's go to another question. Let's go to question number 4. We go to question number 4. Now, here it says consider set C. Consider set C. Set C equals to X such that, remember I said this one means such that. This column, please pay attention. This column means what? Means such that. It means such that. This is what it means. In English, it means column, right? In math or in set, it means such that. Okay, it's an like exclamation, explanations, and so on and so forth. Okay, say means such that. Now let's take a look at it. Say consider set C, and set C equal to X, such that you now read this inequality. It's an inequality. Okay, such that X is lesser or equal to 8 and is greater than or equal to 2. So if you are asked to give the value of X, from this inequality, you divide set C. You say C is equal to, this set C is equal to, when you're writing set, you open a coarse bracket. You see, they say X is equal to X, and X is lesser than or equal to 8 and greater than or equal to 2. Meaning greater than or equal to 2, meaning from 2 to 8 only. 2, 3, 4, 5, 6, 7, and 8. Okay? So these are the numbers that are found in set C. By definition of that mathematical iteration, if you want to enumerate the numbers, these are what you're going to get out of what this question has stated. It says set C is equal to X such that you read inequality to the right before you read it to the left. You read it to the right before you read the X to the left. Okay? This is how we read inequality. We say X is lesser than or equal to 8 and is greater than or equal to 2. So these are the numbers. If you describe the set, describe the set. The sets are the elements of numbers which include a natural counting number between 2 and 8. Natural count is a set of elements, or the set C are elements of natural counting numbers between 2 and 8. And 2 and 8 are inclusive in this consideration. Okay, so you are numbers between 2 and 8 and which are inclusive in this consideration. Write down 2 elements of the set. Okay, you can write 2 other elements, which means you'll be wondering, is there any other 2 other elements that we're going to write from here? Because the numbers are just inclusively from 2 to 8. Numbers are just inclusively from 2 to 8. So where are other elements? You can write 5.5. You can write 7.5. Okay, any number between 2 and 8, whether it's decimal number, can be inclusive in this scenario. Is that okay? Now let's move on quickly. Is this set finite or infinite? This is finite. Why is it finite? Because it's just 2 to 8. That's all. That's the end. It's a finite set. So here, you're going to pause the video and you try your best to solve these questions. Like you see January, March, and July. These are months in a year. A set of months. Describe this set, months of the year. This is the description for this set. Write 2 more other elements. You can write August, December, any other 2 of the months that is not here. These are days of the week. You see Sunday, Monday, and Tuesday. Days of the week. Write 2 more other elements. You can write Wednesday and Thursday and Friday, whatever. Is it finite or infinite? It's finite because there are only 7 days in a week. It's finite. So and so on. So you try. You pause this video and solve this question. Now let's go to what we call the subset. Let's go to what we call the subset. First and foremost, what is a subset? What is a subset? Okay? We're going to start maybe by giving a simple example. If you have elements that are found, if you have elements in a set and they are either individually found in another set or collectively found in another set, they are called the subset of that set. If all the elements of set A are also elements of set B, then set A is said to be a subset of set B. Okay, if all the elements in set A are also found in set B, then set A is a subset of set B. Now this is exactly what I'm saying. Let's try an example. Let's say we have set A. Let's define set A as, let's use a 3-letter word. Okay, let's use DAS. Let's use DAS. A 3-letter, not a 3-letter, yes, just D-A-Z. D, comma, A, comma, and Z, comma. Let's say we have set A to be this. Okay, now let's find the subset. What do we mean by subset? This is a set A. Now, every other set that is part of this, whether wholly or partly, is called a subset of A. Now, let's define set B from set A. Let's get a set B from set A. If I write set B, if I write the whole set, is a subset of itself. Let's start with the whole set. So the whole set is a subset of itself. So if you write DAZ, it's also a subset of itself. If you write DAZ, it's a subset of itself. Okay? So whole set is a subset of the main set, number 1. Now, number 2, let's begin to look at, this is when you have exclusively used the 3 letters. Now let's begin to write 2 letters out of this. We have DA as a subset. We have DA. Let's start with 2 letters first. We have DA as a subset of DAS. And then we have set D. We have AZ as a subset. We have AZ. We have AZ as a subset of DAZ. Okay. And then set E. We have DZ. Set E. We have DZ as a subset of DAZ. DZ. Okay. And then Okay, I think we've enumerated the three cases. Now we go to one case because three cases we have 1, 2, 3, right? Enumerated three cases. We have this, DA, AZ, and DZ. Now the next one is a 1-1 set. Let's go to 1-1 set. Okay, set F. Let's say set F will be equal to element A only. Element A only. Set G. Set G will be element D only. Element D only. D only is a subset of the whole DAZ. Then set H. Set H is Z. Only Z is a subset of the main set. Only Z, so we've given each one, right? We gave 2, 2. We started by giving all three. We started by giving all three as a subset of the main set. We gave 2, 2 as a subset of the main set. We gave 1, 1 as a subset of the main set. After 1, 1, there's one set remaining. So set I is called the empty set. An empty set is a subset of the main set. So you see that we write empty. There are two ways of writing empty set. Either you write like this, or we write two quotes bracket facing each other without any number in it. Two quotes bracket facing each other without any number inside it. Okay, like this. This is an empty set. Either you write empty set like this or you write it like this. Okay, so this is what we mean by subset. From B to I, they call the subset. From B to I, they are subset of set A. They are the subset of A. So the whole set is a subset of A, and the 2 out of 3 are subset of A, and then 1 out of 3 are subset of A, and empty set is a subset of A. Now this will lead us to what we call the proper subset. This will lead us to what we call the proper subset. Okay? This will lead us to what we call the proper subset. Now let's take a look at that. Before we go to proper subset, let's quickly look at the example given in the book. They gave us 3 names, 3 girls, Winnie, Natalie, and Ima. They form a set A. And set A is defined as Winnie, Natalie, and Ima. So now let's take a look at all the subsets. The whole set is a subset of itself. Winnie and Natalie is a subset of itself. Winnie and Ima is a subset of the main set, is a subset of set A. Natalie and Ima is a subset of set A. Winnie alone is a subset of set A. Natalie is a subset of set A. And Ima is a subset, then the empty set is a subset. So I think we already got the concept of a subset. Now how do we write the symbol of a subset? How do we write the symbol of a subset? How do we write the symbol? Subsets are written in this format. We write something like letter C and we put something below it. So if you want to say B is a subset of A, you write B. And then you draw this, and then you write A. So you are saying, if you write this symbol, it means you are saying set B is a subset of set A. Set B is considered a subset of A. That's the meaning. Set G is a subset of set A. It's a subset of set A. Set A is the main set. Set A is the main set, and so on and so forth. Now let's go to what we call proper subset. After we've learned about subset, there's what we call proper subset. Now let's take a look at C, D, E, F, G, and H. They are considered proper subset. Let's take a look at that. Let's go back and take a look at that. From C to H. Now let's take a look at from set C. You know that set B is the whole set. So the whole set is not a proper subset. It's a subset, but it's not considered proper subset. Because you are saying the whole set A, you are listing them again as set B. So it's not a proper subset. It's just a set. It's a subset, but we don't consider it as a proper subset. Now from the proper subset, start from set C. Set C to set H. I is not also a proper subset. These are the proper subset, these ones. These are the proper subset of the main set. So these are the proper subset from set C to set H are the proper subset. They are the proper subset because they consist of 2 out of 3 or 1 out of 3. They are called the proper subset. They are called what? The proper subset. So set C to set C, D, E, F, G, H, they are considered what we call the proper subset of A. They are the proper subset of A. Now, how do you write proper subset? The difference between subset and proper subset, if I want to write C, okay, let's change this. We want to write C. We want to write C, a color that's more conspicuous. Okay, we say set C is a proper subset. Okay, wait, let me erase. Okay. Okay, we say set C is a proper subset of A. This is how you write. The proper subset looks like C itself. You don't put anything below. If you put something here, it means it's a subset. But when you don't put anything below it, it's called proper subset. It's called proper subset. Okay, it's called proper subset. It's not C, but a symbol like that looks similar. It's not letter C, but it looks similar to letter C. A bit similar. Like inverted U. Not inverted, sorry. A slide U. Okay, so you say C is a proper subset of A. D is a proper subset of D is a proper subset of A. Okay, this is how we write the symbol. Now let's take a look at an example to see how far we can go with this. Let's take a look at an example. Okay, and let's be fast. Okay, we say set A is 1, 2, 3 to 10. List set subset B even numbers. So subset B, they say even numbers. So subset B will be equal to all the even numbers from 1 to 10, starting with 2. Okay, 2, 4. Okay, let's just save time and let's take a look at it from here. We say set B will be 2, 4, 6, 8, and 10, right? Look at it, the subset, because they are even number. The even number set are 2, 4, 6, 8, and 10. Now, list another one. List subset C, prime numbers. Now, prime numbers, subset C, prime numbers. 1 is not a prime number. Prime number is 2, 3, 5, 7, right? In 1, 2, 3 to 10, 9 is not a prime number because you can find other factor besides 1 and itself. So the prime factors, prime factors are factors that only have 2 factors, 1 and itself. So the prime factor from 1 to 10 is 2, 3, 5, and 7. 2, 3, 5, and 7. So at this point, you pause the video, pause the class, and solve these questions for your understanding, for a better understanding. You pause and solve the following questions. Question 1 to 4. Now let's go to the next one, which is called the universal set. The universal set is a set of all integers. The universal set is a set of all the things that have been given to you. It addresses all the elements that are found in the problem that has been given to you. Okay, or it addresses all the elements that are found in the problem that has been given to you to solve. So when we say the complement, there's another terminology we use in the universal set. We say complement of set A. The complement of set A means all the elements that are universal set but they are not in set A. The things that are universal set that are not in set A. For example, if we want to give an example, okay, we're going to look at an example. Just understand it. The universal set is a set of all the integers that has been given to you, okay, in that particular problem, for a particular problem, for a given number. All the sets, all the numbers, all the elements that are found in that problem are called the universal set. The complements of set A are all the other elements that are in the universal set, but they are not in set A. Now let's take a look at an example so that will be clearer for us. Now we say universal, look at the symbol of universal set, like E in an italicized format. Okay, this is the symbol of universal set. If universal set is 1, 2, 3 to 10, okay, we've given universal set 1, 2, 3 to 10. I will give it set A to be 1, 2, 3, 4, and 5. This set A. Now, what is A prime? A prime means complement of set A. This prime, when you see prime, we're referring to the complement of set A. Okay, meaning what is in the universal set but not in A. What is in the universal set but not found in A. What are those numbers? 6, 7, 8, 9, and 10, right? 6, 7, 8, 9, 10. They will be the complement of set A. So A prime, this prime, A raised to power small prime here, it's what we call the complement of A. So the complement of A is 6, 7, 8, 9, and 10. Now let's see this one, question number 2. If universal set is all 3D shapes and P is prisms, what set is represented by P? P prime. P prime. It means any other 3D shape like mensuration cylinder, all other 3D shapes like cylinder, like without prism. Every other one you will know, like pyramid, like cylinder, like cuboid, like sphere, any other 3D shapes without the consideration of prism. If prism is set P, P prime will be any other 3D shape. Now let's go to the part we call the set notations and the Venn diagram. Set notations and the Venn diagram. Let's quickly take a look at that. Okay, let's take a look at that set notation and the Venn diagram. Now Venn diagrams, they are a way of showing set in a diagrammatic manner, in a diagrammatic way. Drawing a circular diagrams and rectangular shapes to put numbers in it is called the Venn diagram. Is that okay? Now it's a way of showing set, and for set that overlaps, and to show their overlaps, and those that do not, to show how they do not. And for those that are found that are subset, Venn diagrams are used to express subset and proper subset as well. Now let's take a look at an example. Now we have set A, 2, 4, 6, 8, even numbers 1 to 10, even numbers 1 to 10. Now we can represent this in the Venn diagram. To represent it in a Venn diagram, you just draw a circle and spread the 2, 4, 6, 8, and 10 inside the circle. That will show our set. That will show our Venn diagram set. Now if you have two sets, in the case of two sets, you have P, set P equals to 3, 6, 9, 12, 15, and 18, and you have set Q equals to 2, 4, 6, 8, 10, and 12. This can be represented as what? Now, you have to first of all find the intercept between these two. You have to find the intercept between these two. The intercept means what is common between the two sets. The intercept means what is common between the two sets. You look for the numbers that are in set P and also in set Q. I can see 6. 6 is here. 6 is also here. And then I can see 12. 12 is here. 12 is also here. So those intersect, those two intersect, 12 and 6. Okay, these 12 and 6, they're common to both set P and set Q. So we're going to write them as overlap. We draw two circles to overlap each other. Those numbers that are found between in set P and set Q, we put them in the overlap. We put those numbers in the overlap, okay? We put them in the overlap. So we shade, let's look for a faint. Okay, we shade the overlap. Okay, this overlap, this is the intercept. It's called the intercept of set P and set Q. Intercept. The intercept is the overlap. What is common to both P and Q? Only the element of sets that are found in P and Q is what we will include in the overlap. Only the elements that are found in set P and set Q are those ones that we include in the overlap. Is that okay? Now, every other remaining ones, we will put them in P and Q. For example, 3. For set P, we write 3, we write 9, we write 15, and we write 80. 3, 9, 50, and 80. Okay? So we can show that in a different, with a different color, right? We show that with a different color. So we put these ones here. The remaining ones for set P that are not in the overlap, we put them out. Okay? We put them out. Okay? We put them out here. Okay, let's take a look at the other one, set Q. What are the other elements that are not in the interset, that are not in the overlap? The other elements that are not in the overlap, we bring them out. For example, we take a look at this 2, 4, 8, 10. 2, 4, 8, 10. So we spread them out here. 2, 4, 8, 10. We spread them out in this set. So this is how we draw a Venn diagram. This is how we show the numbers in a Venn diagram. Is that okay? Now let's move on quickly. Here you pause the video. And then you're able to answer. Look at it, what we've said. This is a symbol for interset. Interset is like N, but not really N. It's like N, something like this. Okay? This is the interset. P interset Q is only 6 and 12. And that's why we wrote them out here in the overlap. The interset must be written in the overlap. Then the remaining element for P, you write them out here. And the remaining element for Q, you write them out here. Is that okay? So P interset Q is equal to 6 and 12. Okay. Now 6 is an element of P interset Q. And 8 is not an element of P interset Q. See how we write the mathematical language? See the mathematical language. 6, see this 6 is an element of interset P, is an element of P interset Q, and 8 is not an element of P interset Q. That's the mathematical language. This interset, this word interset, is given with this symbol that looks like N. It's given with this symbol that looks like N. Now here are other example for union. There's another term we call union. For union, we give you X 1, 2, 3, 1, 3, 6, 7, and 14, and Y is 3, 9, 30, 40, and 18. Now for union, you also find the overlap. What is common? There's 3 here. There's also 3 here. There is 14 here. There's also 40 here. So this is the interset. P interset, sorry, not P now. We're talking about X. X interset Y. X interset Y is equal to what? Is equal to 3, 14. 3, 14, right? Is equal to 3, 14. Okay, it's equal to 3, 4. So you write the 3, 14 in the overlap. Then every other remaining element, you write them for X. 1, 6, and 7. So you write 1, 6, and 7 out here for X. And every other remaining one for Y. 3 and 9, 30, and 80, you write them out here. 9, 30, and 80, you write them out here, which is remaining for Y. Okay? Now, what is a union? Now, let's go to union of two sets. Let's go to union. The union of two sets is everything that belongs to either of the set or both of the set. And the symbol is U, something like U. The symbol for union is like U. Interset is like N. Symbol for union is like U. Now, for example, this X and Y, let's find the union of X and Y. It means every number that is here must be written out in the union, both X and Y. But don't repeat the number twice. So you write X union Y is equal to, there's 1 here, you write it down. As long as it's in either of them or both of them. If the number is either here or here, you must write it down. So 1 is here, you write it down. 3 is in both, you write it down only once. 6 is here, you write it down. 7 is here, you write it down. Then you look here, 9 is here, you write it down in union. 30 is here, you write it down. 40 is in both of them, you also write it down. And there's 18 here, you write it down. So all the numbers that are here and here will all appear in the union. Will all appear. So when they ask you to shade the union of X, X union Y, shade the union X union Y, then we're going to shade the whole thing. Let's say, if they say shade the union, we're going to shade the whole thing. This whole place. We're going to shade it. This is the union, okay? Okay, be careful when you shade it so you don't shade outside. Okay, you shade it everything in X union Y. Union is everything, okay? Or like the interset where we shade only the overlap. Union is everything, okay, as long as you don't include the universal set outside, in case we have the universal set. Okay, now this one, the whole thing is called the union. Shade everything is called the union of the two sets. Now let's go to the case of a subset or proper subset. Let's say, for example, we have set J is 10, 20, 30, 40, 50, 60 to 100. 10 to 100 and in 10, 10, okay? And set K is 60 and 70. You can see there's 60 here, there's 70 here, there's 80 here. And this K is found inside J. This 67, this set K is found inside set J. This set K is found inside set J. So how do you show it in a diagram? So you first of all draw the big one, which is set J. You write 10, 20, 30, 40, 50. When you reach 50, you go straight to 90 and 100. Now the 60, 70 and 80, you draw K inside J because it's a subset of it. You draw set K inside J and you put the 60, 70, 80 inside the K. And because K is also found inside J, it means these numbers are also inclusive for this J. Is that okay? So that's that for subset and proper subset. So you pause the video and try to do these questions and shade where is necessary. Okay? And solve all of these questions as it were. Pause the video, solve all these questions, and to show how far you have improved, how far you're getting better. Is that okay? Now let's move on. These are a lot of questions for you to get better. Okay? Now let's move on quickly to setting problems in set notation. Problems involving set notation. Now here, this is where we begin to use our diagram and solve equations, solve the number of students in a class or whatever, and then we begin to calculate. This is where real calculation comes in, but it's very easy if you know how. Now let's take a look at this. Say in a class of 31 students, you have 31 students in this class. Some students do physics, some students do chemistry, they study chemistry. Now if 22 students do physics, 22 students study physics, and 20 students do chemistry, 20 students study chemistry, and 5 students study neither. Neither means they don't do either of the two subjects. Calculate the number of students that take both of them. Calculate the number of students that do both. So what we do, the number of students that do both, we're going to show it. Okay, first of all, you draw a Venn diagram. Once you draw a Venn diagram, you draw overlap, set P for physics, and C for chemistry, the overlap. So those who do both, you don't know, you can call it X. You can call this place X. Or you call it Y, it's up to you, whatever letter you want to use. You call it X, we don't know. They say we should find the number of students who study both. Now here, for physics, it will be, they gave us physics, 22 students. The 22 students, some of these 22 students, they are also in this overlap. So to find here only, physics only, this space is called physics only. So you must say 22 minus x. 22 minus x for this place. To find this place, chemistry is 20 students. Look at those who do chemistry is 20 students. So to find chemistry only, you must say 20 because this chemistry includes even this place, this overlap. So to find only here, you must say 20 minus this x. So you must say 20 minus x here. So here, this is how we have 20 minus x for the chemistry students. Now remember they say 5 students study neither. So you draw a universal set and put 5 out of these two circles. You put 5 out because they say 5 students study neither. Neither means none of these two subjects. Neither means none of the two subjects. These 5 students don't take physics, they don't take chemistry. So you put them out here. Now once you know this, and you know the universal set is equal to what? You draw this universal set, you know the universal set is equal to 31, the number of students in the class. Equal to the universal set equal to the number of students in the class. So we're going to add all of this up, we say equal to 31. We're going to add all of them up, you say equal to 31. So we start from 22. So you say 22 minus x. 22 minus x, this 22 minus x. We write it out. Then we say plus x. We say plus x. We want to find both, those who study both subjects. X represent the number of students who study both. Remember that. X represents the number of students who study both. Then we say plus 20 minus x. Then we say plus 20 minus x. plus 20 minus x is equal to, no, plus 5. Remember the 5. Don't forget this 5. Plus this 5 is equal to 31 students in the class. Plus 5 is equal to 31. Now let's add up. Now this minus x, we cancel this plus x. 22 plus 20, we have 42, plus 7, plus 5, we have 47. So we now have 47, right? Is it 47? 22 plus 20, we have 42, plus 5, yeah, 47. Then minus this x. Remember, there's still one minus x left. So we say minus x is equal to 31. Is equal to 31. Okay, so what I will do, I'll bring 31 to this side. I'll bring x to this side. You know, you want to find x. There's nothing like minus x. You have to bring it to the other side. So I'll have 47 minus 31. If 31 comes to the left, it becomes minus. So you say 47 minus 31 is equal to x. You bring x to the right side, it becomes x. So 47 minus 31. So you can say 7 minus 1 is 6. And 4 minus 3 is 1. So x equal to 16. X equal to 16. Or 16 and x, they're equal. So students who study both subjects are 16 students. Students who do both subjects, there are 16 students in the class. They're doing physics, they're also doing chemistry. Now if you want to know who study physics only will be 22 minus 16. 22 minus 16 will be 6. So physics only will be 6. Physics only, those who do physics only will be 22 minus 16. 22 minus 16, which is 6, right? Minus 16 equal to 6. These only, those who do physics only. Chemistry only will be 20 minus 16. Chemistry only, students who take only chemistry in the class, they don't do physics, will be 20 minus 16. 20 students in the class, 20 students doing chemistry minus those who are doing both. You get those who do chemistry only, and that will give us 4 students. 4 students are doing chemistry only. Okay, so this is what it is for the Venn diagram. The rest are questions for you to solve. Okay, as many as you can. Okay, as many as you can. If you want us, we can still do one for you from the exercise. Look at this one, same thing. Say in a class of 35 students, 90 take Spanish. So you just draw a Venn diagram for Spanish. Another one overlap with the next subject, Spanish. It says 90 students take Spanish, so we write X here. Spanish is 90. And French, 80 students take French. 80 students. So if you want to do this, it's the same thing we just did, right? Here, you come here, you say 90 minus x. 90 minus x. For here only, 90 minus x. Is it? And 80 take French and 3 take neither. So we draw our universal set. We draw our universal set. 3 take neither. You put 3 here. Okay, here is x. Those who take both. Here is x. Those who take both. And here is 80 minus x. Okay. Now they can ask you to calculate both those who do both French and this, which is here. Meaning find x. Those who do French and this. And there are class of 35. So we're going to add all of this together. 90 plus 18. 90 plus 80, we're going to get 37, right? 37. 37. This x, we cancel this x. Minus x plus 37 plus 3, that's 40. So I have 40. 40. We have 40. How did I get 40? I said 19 plus 18, we get 37. Okay, this minus x, we cancel this plus x, and then plus this 3 outside, that's 40, and then minus this x. 40 minus x equals to 35. Equal to 35. There are a class of 35 students. All the students in the class, they are 35. Okay, so you bring 35 here, you bring x here. So here will be 40 minus 35. equal to x. 40 minus 35. 40 minus 35 equal to x. So x equal to 5. So those who study both subjects, there are 5 students. Those who study both subjects, both French and Spanish, there are only 5 students who do both of them. The next question says just Spanish. Those who do just Spanish. So to find Spanish only, just Spanish means Spanish only. So those who do Spanish only will be 19 minus 5. 19 minus 5 will be, let's assume this is A. Okay? A part of the question. And this is B part of the question. This is B part of the question. Spanish only will be 19 minus 5. Spanish only will be 19 minus 5. 19 minus 5 equal to 14. 19 minus 5. Because here is for Spanish only, okay? Here is for Spanish only. Without French. Without French interference. Spanish only is this place. 19 minus whatever you get for x. We remember we got 5 for x. So you say 19 minus 5. Which gives us 14, right? So we get 14 here. That's the B part of the question. Now the C part of the question says we should calculate those who do French only. Just French means French only. Meaning here, only here. Okay, meaning here, only here. French only is only this place. Only this place. 18 minus x. French only. So 18 minus x. And x is already 5. We've calculated x to be 5. So we say French is equal to, French only is 18 minus 5. So 18 minus 5 we get 13. 18 minus 5 we get 13. Okay, so this is how you attempt the questions, okay? This is how you attempt the questions. So you pause the video and solve. We've done question 1 for you, exercise 1 for you. So you do the remaining exercise. Okay, we've done this one for you. You do 2, 3, and 4 and come to the student assessment and try to solve the questions in student assessment. So with this, we've come to the end of today's class. Thank you for joining us.